Hi, this is the Mad Scientist back in the game conducting our Trial 2 Test 1, which is Springs. Today is Friday, January 27, 2012 at 3:38 p.m.
And as we already did this before the video, the mass of the egg is 55.48
grams, and the saran wrap, in case that the egg happens to crack and has a really bad damage done to it, then we will subtract the mass of the saran wrap in case we can't take it off. And the mass of the saran wrap was 1 gram.
And now we're going to start conducting our experiment. And this time the added feature to the car is springs. And the egg that we're going to use is there with my partner, and she will show you.
And on the egg, we directly marked Trial 2 Test 1, which proves that we are using different eggs every single time and not cheating.
And as you can see, the added feature to the front exterior of this car is a spring, and it just fell off. And what we'll do with this, we'll just line up the motion sensor with it so that it will touch the wall at the same time.
So right now, my partner is putting the spring on the blue physics
So
car.
it just bounces like that. So this isn't our hypothesis. Our hypothesis states that we think the silly putty would work in this part,
because it absorbs the force and would probably slow down the whole crash.
And as you can see, we wrote TR2 representing Trial 2 and Test 1.
Okay, and I will just place it here. And basically what's going to happen is we propel it with this metal piece, and then it will, as in our inference, this will propel from the metal piece into this wall, and will probably continue coming back if it has a great amount of force put into it. And also, we will be measuring the force with this calculator right here, and this motion sensor.
And also the platform is to simulate a road, and this is just the place where it crashes into, and we'll just measure the force.
Okay, right now we are duct taping the motion sensor onto the car,
making sure this matches off.
We'll just cut off the excess duct
And
tape right now.
when we actually conduct the experiment, you won't be focused here because what the calculator calculates is much more important. So it will be zoomed in until you can see the numbers. And but in the background you can hear it shooting, so that you can know that it's true, and the force here, and we're not cheating. So
because when we are testing this, the graph that we will show you soon or later in our experiment, it will be moving very quickly. So you can see it's basically a line graph which shows past time, like changes over time. So it does pass by really quickly. So that's why you will be focused on the calculator instead of the whole entire trial.
And as you can see, they match up. So when we just shoot it, so we'll bring in this this contraption back to the 31.5 centimeters line,
and the front of the car will line up with the 18 centimeter line.
And she'll just count 2, 3 before and after.
And the reason that we are counting to 3 before is because the calculator for the motion sensor to send the messages through this wiring to this calculator, it will basically have to take a little bit of time. So it could have a late reaction. So the graph will probably have a late graphing to it. So that's why we will be counting to 3 to show all the changes over the time.
And now we're just going to zoom in, and we're hoping it will focus.
We'll just turn the calculator on right now.
And
so it will load right now. So right now, as you can see, it's turned off. So once we turn it on, it just takes a little bit time to load. But once it comes on, it will have a red Newton, which measures how many newtons it is, which is right here. And right now, to have more detail put into our experiment, we'll be pressing the graph button.
So and we'll make sure this is plugged in, because then it has line like that. Okay, and then we'll just be recording the calculator so you can observe how the graph goes.
Okay, so right now my partner will test the experiment right now. And we'll get all the wiring off. And then we'll make sure that it presses the wall. And if it does not happen to touch the wall at all, we'll just redo it, because we are sure that the egg is not cracked. But in case we have to do it, we'll have to check the egg. So right now we'll conduct the experiment right now. Ready? So I'll count to 3. 1, 2, 3. 1, 2, 3. So as you can see, I basically counted to 3 on here. So if you can look at the calculator, see what happened. It had a straight line. It had like a last time right there, the straight line right there. And we pressed the lowest point on there. And the force was negative 12.799. But we'll just ignore the negative. And the total elapsed time was 3.50 seconds. So we'll be doing a quick sketch of the graph right now.
And for the time, we'll take off the whole number, because our physics teacher had told us that. And right here, since it's in the middle of the graph, we just take off the whole number. So the force was 12.799 newtons, and that's really close to the limit that this motion sensor does take. So, and we set it like that so it won't go overboard if it crashed into something. And the time was 0.50 seconds, since we take off the whole number. And we also did a quick sketch of it. And now we're just going to find the velocity. And
right now we will be showing you our notebook.
This is our data, and while I calculate this, my partner will examine the egg.
Okay. So right now, as you can see, we will take the motion sensor off of the egg right now, as carefully as possible, and place the motion sensor on the platform, and we'll just examine the egg to see if any damage was done. So we are just currently unwrapping the saran wrap right now. So as we examine the egg right now, there is it's a really faint crack, but you can barely see it. So we'll do a close up right now. It's right where the words are listed. If you can see, it's a little bit blurry because of the camera, but if you can see it, there's a faint crack going on right here. Right here. Okay, so but there very little damage is done to it, so we cannot actually we cannot actually conclude that the springs is the most unsafe material to be put on the car yet.
Because it just had a little crack, and as you can see right here, we just calculated the velocity and the acceleration. And as you can see, velocity is basically 36 because the displacement was from the white line that we showed that the front of the car lined up with, which was 18 centimeters from the wall, so that's our displacement, and our time was 0.50 seconds, and that equals 36. And we take the velocity and divide that by the elapsed time again, so we get 72. So that's our velocity and acceleration, and we're just going to take some qualitative data, and also while I do this, my partner will measure the egg's mass. And we're just going to zoom in onto the triple beam balance that our science teacher had lent us.
Right now, I'll just take this. So as you can see, it is lined up at 0 right here, and it is set up to measure the mass of it. So we'll unwrap the egg once again.
And we'll make sure.
Trial 2, test 1. And then we'll carefully place this on the triple beam balance, if we can get it to stay. Okay, so we'll be very careful. So from our past experiments, we have concluded that each egg is less than 100 grams. So we'll try around 50 right here. So right now it's still up. So we'll try this one, and the next one, and it's too heavy. So we'll do the ones now. So it's still light. So we are still trying to move this down. And my partner will do the most accuracy, and she will tell you what the actual mass of the egg is after the crash.
And as you can see, it's matched up with 0, and the new mass of the egg is 55.6. But that's just a little bit under, so we'll just
So we have to make sure that each mass is very accurate and perfectly lined up with the 0.
And now it is lined up with 0 completely. And its new mass is 55.3.
So it basically decreased a little
by
bit.
0.18 grams. So that must have meant it might have lost some mass, and it's tracked in of which it crashes into the wall. So that might be a thing to investigate in. And some qualitative data that I wrote down was that it had a faint crack, and the motion sensor, when it hit the wall, the motion sensor got kind of twisted off. And it didn't. The car didn't bounce back this time because that was what it usually did. And now we're just gonna wrap this up and save it, just in case we have any example or anything. So the mass of the egg also decreased.
So we'll be carefully wrapping this so that any other damage is not done on the egg.
And that basically concludes our test 1 in trial 2.
Thank you. Bye.